All right, everyone, let's focus, please. It should be a fairly straightforward lesson from yesterday. As long as you know the area under the curves, you should be able to find area between curves. All right? It's not. It's not, in a way, it's not very difficult if you know area under the curve. But at times it could be a little bit confusing, that's all. It could be. So you got to be really looking at the area as a whole. Alright? Now, so by the end of the lesson, you should be able to recognize the importance of the points of intersection between two curves when determining the area bound between two curves. Alright? Important to know where the intersection point is. You should know how to derive the subtraction method of calculating area trapped between curves. And finally, solve area under and between curves problem, whereby the region requires to be split and calculated using addition of separate integrals. Now, let's start thinking about area between two curves. So, if I've got two curves, one is y equals fx, one is y equals to gx. Alright? The area between them, this little bit here, can be found by the difference between the area under the upper curve. I'll show you in a few minutes, but just using my hand, showing you this is the area under the upper curve. This bit here.
Yes, two, right? Two.
Alright, this is the area under the upper curve.
Three.
And then area taking away area under the lower curve. The lower curve is this one. Alright, taking away that.
Yes.
That's it. So therefore, you have this area by itself. You've got one area, take away the other. Now, I need to prove to you that it is the same no matter whether this is translated up or translated down. Alright? Let's have a look at the first situation, which is this. So, if I do an integration of the upper area, so you know that the bound is a to b. So I can integrate from a to b to find this area here. Alright, this is y equals fx. Then y equals to gx, the area there is actually integrating from a to b, definite integral g to x. Alright, area under the curve. So if I put everything together, the area is actually integrating from a to b, fx dx times integrating g to a to b, gx dx. And of course we know that we can integrate this function, take away the function dx. Now remember, fx is always the upper curve. So you need to be able to identify the upper curve or the lower curve. Alright? Now, the next situation, if I actually translate it all the way down. Alright? This time, the same curve, but I added a translation. So I have actually moved it down under the whatever the x-axis. So here you've got this case, this big area here. Take away that bit to give you a. All right. So again, you know the area under the curve. Doesn't matter whether it's above or below. Area under the curve is integrating from a to b. Fx dx. Same with this one. Area under the curve is integrating from a to b, gx. Now, because this is negative, this is negative. Alright, negative sign area. Negative take away negative. You will actually have a positive area. And it's always the same. Y equals fx is always the upper curve. So really, it doesn't matter whether you're translating up or down. You will get the same answer, even if you've got a situation where it is in between. Alright? If you want to find those two areas, what you can do is to find the area of this first, and then find the area of that. Alright? You will end up getting the same thing. So, make sure that you can identify the upper curve and then the lower curve. And as long as you know the area in between the curve is integrating from a to b, fx take away dx, you'll be fine. Alright? So now what I'm going to do is let's do some examples. All right. Now, the focus question is why are the points of intersection important?
Bounce.
Yeah, the bound. You definitely need to know bound. If not, you won't be able to, if you don't know the point of intersection, you will not be able to find the area. All right? Let's start off with this. Can you sketch y equals x cubed minus 4x and y equals 3x squared? Remember what I say, generally, if you don't have a graph, sketch it. Now, you can find the intersection point first, or you can find the roots first. The way I've done this one is actually I found the point of intersection first. How do I find the point of intersection? I equate x cubed minus 4x to 3x squared. Correct? Yeah? So, rearranging it, I can actually take all the x's to one side, and then I can actually factorize it, and I found that when x is 0, y is 0, when x is 1, y is 3, and when x is 4, y is 48. Now, really, the y itself, the y value itself, or the y coordinates itself, is not as important here. We are looking at the bound, which is the x. Alright? Later, there's another question, you'll know why y is important. At this stage, it's not as important for this question.
So,
Yep.
I think it's x minus 4, x plus 1. Instead of x minus 1.
Is that right?
Yeah.
X minus, yeah, that's right, x minus, yep, that's correct, thank you.
Minus 1.
Yep, yes.
Yeah,
One.
minus
So it is x minus 4, x plus 1, correct. It is minus 4. I'll sort that out. All right, yep, okay. So, now, then I find the roots. So the roots for y equals x cubed minus 4x is x times, taking the x out is x squared minus 4. So therefore, you know x equals to 0 or plus or minus 2. You got these 3 points. You know that this is a positive cubic. As x approaches infinity, y approaches infinity. So it's therefore that sort of shape. All right? It will be this sort of shape. So you can just sketch it. And that's it. Label it y equals x cubed minus 4x. All right? And then you've got y equals 3x squared. You know that this is going to be a parabola, 3x squared. So when you can work out the roots, you don't even have to do that. You can just write down the root is 0. And you know you can sketch it. All right? So I sketched it correctly, but I did not do that correctly in terms of x plus 1. So you now know from here, you've got minus 1 and 4. That is your bound. All right? That's your lower bound and that's your upper bound. You want to find the area of this and the area of that. All right? The combined area. Now, here, you can see that this bit from minus 1 to 0, the upper curve is actually y equals x cubed minus 4x. Here, the upper curve is actually 3x squared. Y equals 3x squared. So, when you do your integration, when you find your area, write it out properly. So you start off from one bit, from integrating from 1 to 0, x cubed minus 4x minus 3x squared dx. That is the first bit here. That little bit here. And then you will use 3x squared, take away this. Alright? So this is the bit that you really need to understand. How you can find both bounds and where the roots are. You may need to integrate this bit and integrate that bit. Alright? So there will be a situation that you may have something like this. You may have to find area between here and here. So there will be that bit and that bit. Alright? So you need to think about how you would do it. Now, and therefore write it out properly. And if everything is right, it's 32.75 units. mean, even if you give it to me as 32 and 3/4, that's fine. Not a big deal. See how I've done it? I've actually recognized that the first bit, that is the upper curve, that is the lower curve. And then the next bit is the upper curve and the lower curve. Important, recognize that. So you know the intersection, you know the roots, you can sketch it. Then you will be able to do your integration from this point to that point, and then from this point to that point. All right? Any question there? If not, can you try example 2, please? Example 2 is an interesting one. Example 2 is an interesting one. Again, it's up to you if you want to solve for points of intersection first. I would in this case, because you know sine curve is just a sine wave or cos wave, that's all. So you need to know, you know that the highermost, uppermost is 1, lowermost is -1. All right? Find the point of intersection, you see that this would be the bound. So sine x equals cos x. Now you are already given x is pi over 4 to x. The bound is from x equals to pi over 4 to x equals to 5 pi over 4. So if you solve it, intersections, sine x equals cos x. I'm going to ignore everything that's below 0, negative. It's because I've given you the bound. So you can see that tan x is 1, and we don't even have to go anywhere further than 5 pi over 4. All right, sketch a graph. All right, sketch sine x and cos x. And you can see the area that you need. All right, I'm going to stop here. You can continue with the rest. So which one is the upper curve? Sine x, correct? And then the lower curve is cos x. So you need to use integrate from pi over 4 to 5 pi over 4. Sine x take away cos x. Integrating. All right. So I get 2 square root of 2 unit square. Look, the sketching is just sketching for you to know where the upper curve is and the area you're looking at. So just in case, for example, if you are given from pi over 2 to pi. All right? So you'll be looking at this area only, pi over 2 to pi. All right? You still use the same idea. You could do that. Or you are, if you are told that the exact area, now exact area, you must give it in the exact, which is 2 square root of 2. All right, inserts or in a fraction. So you are actually looking at the 2 intersection, but you could be given just between here and here. All right. So you got to recognize the fact which one is upper, which one. Who hasn't got a class pad? We will need a class pad. Definitely need a class pad. If you haven't got one, come and grab one, please. All right. Next, this is calculator assume. Alright, determine the area bounded by the curves y equals x cubed minus x plus 1 and y equals 3x squared minus 2. Now, before you even start looking at your class back, what is the first step? What would your first step be?
Intersection.
Sorry? Yeah, clear the class back, but if you haven't got a class back, what would you do? Sorry, clear the class back, yes for sure.
Intersection.
Intersection, very good. So can you find the intersection with this one?
With class back.
You can use class back, but you still need to write it up. Alright? Use your class back, that's fine. Let's go to your class back. Y equals x cubed minus x plus 1. Y equals 3x cubed minus 2. Alright? Now, it says that for x, the area bounded by the curves, y equals x cubed minus x plus 1 and y equals 3x squared minus 2. For x less than 1. Alright. There's no lower limit, but look at the question, determine the area bounded by the curve. So therefore you need to know the point of intersection after less than 1.
Yes.
Alright, because it's the area bounded. It's less than 1. So there's no lower limit, but the question itself is inbuilt in there. So if you do it properly, right? Go to statistic, oh not stats, wrong one. Graph and table, clear all. Alright, so start off with x cubed
Question we got.
minus x plus 1.
What you say?
And this
Something a little
is
different.
3x squared, take away 2.
It's in 2021 ways.
Drop.
If we actually did this.
Alright, you can see it's something like this. Now,
Yeah.
let's expand it a little bit.
Did you get this?
I actually did, yeah. But I think my keys are wrong. I think I put like 4 keys on one for some reason. But the rest
Alright,
is correct.
now you can see here,
It's pretty simple.
if you find your
Nah,
intersection point, alright,
Gotta be-
there should be another point of intersection somewhere up there. Definitely. I'll show you in a few minutes. But plotting the graph, you really only need to know from x is less than 1. So you do know the bound here. X is less than 1 and the other one is the point of intersection. Correct? So you do know this point and here. You don't have to know anything else, but you need to know this and that. Alright? So, to find the point of intersection, I work through it and I know x equals to minus 1, 1 and 3. So we can ignore 3. 3 is not going to be in the interval. We want anything less than 1. So drawing the graph, oops, I want to go to the next slide just quickly. Alright, so drawing the graph, is that the right one? No. So drawing the graph, it gives you something like this. Alright, now what I want all of you to do is go to your class pad. Once you've got this out, alright, this is between minus 3 and 3. This is from minus 4 onwards to about 4. Alright, now go to integral. This time you're going to use integration dx intersection. Alright, you've got 2 curves, therefore you can use intersection. Alright, let me use my class pad to show you. So here, you go to analysis, GSolve, integral, intersection. You've got 2 graphs. You will come up with the first, you've got 2 curves. So you come up with the first intersection. There, that execute, and then go to the next one by your cursor and that execute. So it will work out your area to be 4 and highlight it for you. The important thing is you need to specify where the starting ending point is. It's because if you have a situation like this, all right, you've got one intersection here, and one intersection here. Do we want this? Do we want both? Or do you want just one? So you must specify where your starting intersection is and then the next intersection. All right, yep.
How do you do this with signed area?
Sorry?
How do you do this with like absolute area?
Okay, if you want to do it as a sign area, what you need to do is first look up, do your definite integral for this. All right? Which is the top area, which is the blue area. And then you do your definite integral for this one. All right? You must realize that this would be this is a bit complicated. You need to work out this bit for that. All right? That it should be a vertical line, and then the area of here, and this area. All right? It's a bit complicated. You want to do it that way. You can use the integration of the top curve, take away the bottom curve. All right? If not, if you just look at the sine area, definite integral itself, you really have to go through looking at this bit first. All right? This is the area under there, and then the next bit, which is this. You've got the area of this and this area. All right.
Will we do that this year?
Sorry?
Will we do that this year?
We have done that.
No,
haven't we?
like.
Yeah. So if you've got a complicated case, what you do is do your upper curve, take away your lower curve. All right. So with this,
No, just this.
this is how it would look like for your class back. But you still need to write things out properly. The intersection by class back, if you go up to this point, I'm pretty sure if you got a class back, you should be able to use a class back to factorize it. All right, and then write down your root, not roots, your intersection, and then state that x over x equals 3 is not included in the domain. So you don't have to consider that. So look at the point of intersection minus 1 and 1, and then you can do that as area. All right? Just make sure that you write it out properly in the exam. Don't just say calculator produce this, don't say calculator produce it. Show your steps. Your steps are important. Now I want you to try this. Again, show the steps with your calculator as well. Alright. Draw the graph with your calculator and then find the area. This one would have to be calculated as you. You must write down the intersection.
What's plane region? Yeah. You sure? No. What's plane region?
Who knows?
So what's plane region?
Hmm?
What's plane region?
Just a flat region, that's all. Just that plane. Yeah. It's just like Cartesian plane region, that's it. The flat region.
there's only 2, right? Because there's this part here, and then just that part there, that's it. But that's why there's 4 roots.
Yeah, that's 3 parts. One here, one there, one there.
Oh yeah.
One more. You have to just add them together. So it's
38.9 units.
you sure on that?
Yeah, I'm sure. So do you have to write how you're working for the intersection, or can you just write your intersections?
You can just write the intersection. I mean,
Yeah.
it depends on the question. If it is calculated,
Screw.
I will assume that you are allowed. You certainly know how to use the calculator to do your factorization, don't you? Do you know how to use your calculator to do the factorization?
Wait.
Factorizing?
Yes, you put in the factorize
No, you don't know how to use your calculator to factorize?
Don't you just put in the factorize command?
Yeah,
So-
factorize command.
Yeah, just use. Hang on, let me write it out. X to the power of 4 minus 9x squared plus 8. Alright, so you factor that. Let me get your
38.9.
calculator.
Yep.
Yeah, okay, here comes calculator. So under Casio
'Cause you gotta write out
calculator,
the
you go to menu, main,
dx.
clear everything.
So we go.
So if you go to type in that equation, x to the
38.9.
power of 4 minus 9x squared
Show it.
plus 8. Click execute. Copy that across and come to the next line. And then highlight it. Go to interactive, transformation, factor. Factor. See, it's factored it out for you. You don't want decimal, just put in as standard. See, it's done it for you. X squared minus 8 and x squared minus 1.
Yeah.
Alright? So I'm sure if you got a calculator, you can do it that way, as long as you write it out properly. Alright?
That's plus 1 as well.
Write it out properly, you know
Yeah.
x equals plus or minus 1 or plus or minus 8. Now, the curve should look something like this.
Yes.
Alright? It should look something like this. Now, what I want all of you to do is to think about here. If you really need to write it up, from here to here, the red one, which is for x squared minus 8, is the upper curve. Alright? From here to here, the red is upper curve. That is the upper curve. So you need to think about this, take away this, take away this, take away that area. Alright? Now, the thing is, if you've got a calculator, you could actually just use your calculator integrate function. Integrate between your two intersections. Now, let me show you. X to the power of 4 minus 5x squared. Y equals to 4x squared minus 8. Alright? Let me get my simulator. Alright, if I type that in, I will clear everything first. Alright, so here I've got x to the power of 4 minus 5x squared. And then 2 will be 4x squared. Take away 8. Tap, tap, and draw it. Now, I want to see right at the end, so I'm going to change that. If I can move that out a little bit. Yep. Alright. We don't know, we can't see the other intersection, so you can't do your analysis yet. You want to get your intersection out. That will be, I think, about 30.
28.
28, is that right? I can't remember.
24.
So,
24.
okay, I'm going to use that. So y will be, y minimum is, let's say, -1. Oh no, hang on, leave it as minus 8.8. And maximum is
24.
30, let's call it. Okay. Now you've got that. So what you can do is go to analysis, go to GSolve, integral. You are integrating between the intersection.
So
Here,
you can do that even without zooming out.
you can you?
Yeah.
I'm not sure, but I don't know.
Yeah.
So you can have this intersection. Now, you need to go across to all the other intersections. You cannot just go across to one. That will give you just the little bit. You have to go across to both. Right to the end, and then tap execute. Then it will work out the, oh, what have I done?
Good question.
So it worked out because I went from one side to the other. So it's now it worked out the area bounded by the curve, which is 38.9019. All right. So it's pretty good in that sense. If not, if you want to go to analysis, GSolve. If I just want one section, all right, let's go for the intersection. I want just the bottom bit. I will click execute, and then there, execute, and it works that out to be 10.4. All right. So it's actually really useful if you know how to use your ClassPad. However, like I say, I will still write it out nicely. All right. Just write it nicely. You can always, if they want exact number, you always use standard in your calculator to come up with the certs. Now, is there a simpler way of doing this? Is there a simpler way of doing this? There is. All right. Now, everyone, focus for a minute, please. All right. You don't need your laptop. You just need to focus here. So I'm going to give you a slightly easier way of doing it. All right. So let me go across to this one. Here, the alternative solution. If we use absolute value, all right. If you use absolute value, it really doesn't matter which one is on top, which is on the bottom. If you know both bounds, you know that this curve, all right, here, from the bottom, the blue one is going to look like, all right, I'll do the red one first. The red one is simpler. It will go this way, all right? Ignore this already, all right? And then the blue one will go from here, reflecting up, down to here, and here the same thing as well. That will be the absolute value.
No, no,
See?
No, sorry.
Is it? No, sorry, it's down. It's
Yeah.
here, sorry. Hang on. Not good. This is somewhere around here. So it should be, hang on. I made a mistake here.
Absolutely. You reflect it upon the x-axis.
That's
the negative values.
that's yeah, going up here and down here. And sorry, obviously. That's better. That's better. So it's going up. This way is going up this way.
Yeah.
This will be going up. Oh gosh. I'm half asleep.
Yes.
That's better.
There we go.
Alright.
Yeah.
So therefore if really if you have the absolute value, even if that's negative, you really have not an issue because it will work out to be an absolute solution. Alright? So that's the thing. Therefore, if you have got that sort of curve,
Yeah, well, just do the normal
it is
way.
possible for you to use the absolute value to calculate the area. Alright? So the absolute value, you know how to use that. In your calculator, you
Bro,
could
just, yeah,
use
just use it
oh,
normal.
not this one. In your ClassPad, you could use keyboard. That sign here. This is absolute value. I think you can also use ABS if I can find it. I think under advanced, if you find ABS, yep. So here, if you go to advanced, ABS, that's possible as well. Or use the two straight line. All right. So under advanced, ABS is also absolute. So either one you could use. Just to make life a little bit easier for yourself to understand this. Alright? Now, the next bit, the last bit, we're going to split the areas into subregions. In some cases, we may encounter examples of regions that are not explicitly defined by upper curve and the lower curve.
So can I please go to the toilet?
So this region needs to be subdivided into smaller region and calculate the total area in question. I missed a word. Alright, smaller regions. Now, for example, this. How are you going to work this one out? You got y equals to square root of x and y equals to x minus 2. Alright?
Yes, add a third line.
You don't have to add a third one. You got two areas, 1 and 2. So the area number 1 is basically working out the area under y equals to square root of x between 0 and 2. Alright? Now, I did show a step of finding the intersection. I want to show you something, alright? You got to realize that we are only looking at this area. Now, if this was not given, you need to find the intersection. Alright? Here, we now know this is positive. Alright? It's positive. Positive square root of x. It's not negative square root of x. Therefore, when you look for intersection, you know that if it is y equals plus or minus square root of x, it would have gone around here. So you got to realize that I'm rejecting 1. Alright? I'm rejecting x equals 1 because this is the bit. 1 is where y equals to minus square root of x. Alright? I am not looking at that at all. So therefore, I'm looking at this function, reject. You will have two solutions when you do it manually. Alright? Reject that. But you can actually read it from the graph if the graph is really clear. If the graph is not clear, you really have to work this point out and reject that point. Alright? Yeah? So just be careful when you look at a question like this. This is positive square root of x, not negative. So therefore you have to reject 1. If you do not have that point, if the graph is not given to you. Alright? Once you've plotted, you now know that you can do an integration. Area number 1. 4 square root of 2 over 3. And then area 2 is a little bit more complicated because you need to look at this pink region here is actually that bit. Alright? Take away the triangle. Take away this triangle.
Why do you reject 1?
Alright, take away this triangle. Where the triangle of this area is half 2 times 2. I need to integrate y equals to square root f from 2 to 4 and then take away the area of triangle. So I split that into 2 subregions. Splitting that into 2 subregions, I get the area of that, which is 10 square root of 3 times 4 square root of 2 over 3. Alright?
So
And
why do you reject 1?
I reject 1 because we are only doing y equals to square root of x. We are not doing y equals to minus square root of x. We are not coming down this way. Alright? So we are only looking at these graphs, the top half of the y equals to. Alright? We're only looking at positive. So therefore, the total area is 10 over 3
10 over 3, yeah.
units square. Alright, last example. I'll let you try it first. These 2 examples are Mr. Alfonsi's example.
0 and 4. Damn.
Again, you got to think about triangle, and this one you've got a square as well.
Wait, why do you have to think about squares?
Why not? Yeah. This is a square, isn't it?
Oh.
Yeah,
Yeah. And this is a triangle. Yeah.
Yeah, yeah.
So you got a square and a triangle to think about.
bro, I don't want to do this, bro.
Not giving any more hints. A square and a triangle.
Not more like Sir,
Yeah.
I get it now. I get it.
Got it? Can you see this triangle take away the something and something, 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 something?
Yeah.
Would you use the intersection between the curves and the line?
It's given. You don't have to worry about it. So you have to start from here. This is 0, 0.
Zero to
This
one.
is 1
Yeah.
and 1 to 2. All right,
So
yeah,
zero-
given.
zero
So
to
this one is very clear. You don't have to worry about finding the intersection.
From 0 to 1, you would use the intersection, but from 1 to 2, you would use the normal. Right?
Still the same. You got to integrate between 0 to 1, integrate between that. Or you can even use, all right? If you don't want to use the triangle, you can use the trapezium formula and take away this bit here. You can use the trapezium formula as well. I mean, when I did it, I was doing it as a triangle and then a square. It's just the way I did it. That's all. I split it into two chunks. But if you like, you can just do one.
Yep.
Integrate from 0 to 2.
Two lines.
This area here.
And then from 1 to 2, you just do between the curves.
All right. And yeah.
Like from here to here.
Which one?
You need a square, take the curve.
Here to
the-
here.
Yeah, you do the square.
You do this and then just do a normal integration.
No, you can't. Because the integration of that is area under the curve. It's not up there.
Between this line.
Yeah. Then what about this bit?
Roof actually
Between this line and
made that
okay.
kind of hard.
Yeah.
Okay, if that's not there.
That's first.
That's the first time
that I
including this area as well.
Yeah, so the first time we did this, I was like, holy
If
shit.
you look at that.
I got through most of it. I felt pretty confident. And then the last part was just, it's still going on.
I didn't even
And by
quite.
that time, I was at the spreadsheet.
Yeah.
That went all fine, and then
And y equals 1 is there.
normalize.
So you are
and
forced to actually look at from here to here rather than here to here to there.
Yeah.
You know what I mean?
ERD, I'm losing a lot of
All right.
marks, and it's 20.
So, I mean, look,
Wait,
you can always try it out my way or you can try out the trapezium way.
Yeah.
So I did it in 2
Get
areas,
enough from the rest.
1 and 2, and then,
Can't believe it was worth a quarter of the whole test.
sorry, what was the part of the whole test?
Oh, we're talking about computer science.
Okay. So this is area 2, and then it works out to be 2/3 of a unit square.
Wait, what?
That's all. And that's the last example I have for you. And it's pretty, I mean, it's not as straightforward as you think.
Wait.
I mean, I did it in area 1 and area 2, but like I said, you can always use your trapezium and take away the area under the curve. That's it. Now, what I'm going to do tomorrow is I'm going to give you a period to work on all this. There are a lot of exercises, area between curve and area under the